The goal of the third generation Venge was, of course, to make a bike that was faster than the previous, but as importantly, we wanted a bike that handled as well as a race bike should handle through rider-first engineering, as well as a bike that was more usable across more courses through the calendar, and that entailed reducing the weight significantly from the previous generation. Of course, some of the most important people for us to get input from were our fastest Pro Tour racers. And so when we asked racers like Peter Sagan and Fernando Gaviria what they wanted in the next generation Venge, they told us, hey, the current Venge that we have is super fast, so yeah, we want it faster, but more importantly, we want to be able to use this bike in more races. I think a lot of times when we hear aero's everything, we mistake that for aero at all costs. Part of the development of the third generation Venge involves our knowledge of where does aerodynamics matter the most, and conversely, where does stiffness and weight matter the most. With goals as extreme as we had for the third generation Venge, with the aero targets, the handling targets, as well as the weight targets, we truly believe that we're beyond the point where any human engineer can realistically create a bike that meets all those goals. And so knowing that, we turned to building an all-new tool called free shape optimization that allowed us to put in all those different targets and organically run through thousands and thousands of iterations where the shape organically morphs until we find a collection of shapes that meet all the different targets that we assign. So using this knowledge, we assembled different aspect ratios from the freefoil shape library into locations like the fork, head tube, C-tube, and C-post, where aerodynamics we know is very, very critical. And in other places where we know stiffness and weight are extremely critical and aerodynamics has less of a role, like the down tube, the top tube, and the chainstays, we use a different set of shapes that were more optimized for stiffness and structural efficiency. As a project, the cockpit on the third generation Venge was kind of a mini story of the entire Venge as a whole, which is to say that, yes, we wanted to make it faster than the previous cockpit, but also significantly lighter and easier to work on. And so to do that, we re-optimized the handlebar shape using, again, a freefoil shape library section, as well as re-engineered the stem, not only to make it stiffer and lighter, but also to be able to integrate housing in an external way. And so by doing that, we preserve and actually increase the aerodynamic performance of the cockpit, but make it significantly easier to work on, as well as stiffer and lighter. No matter how many tools we have, simulation or otherwise, Specialized would not be where we are today in aerodynamics or really racing or any of the products that we do without the wind tunnel. It's truly a lab that we use almost 24/7 in everything that we do, whether it's thermal research, acoustics, or aerodynamic performance.